Okay, I think this will be the last video on the implementation of MyLinkedList. And if you made it this far and you got an idea of how we're doing things with linked lists, you're doing well. Basically, the advantage of linked lists is you move pointers around. And moving pointers tend to be a lot simpler operation, faster operation than dealing with an array and having to force yourself to maintain the physical ordering of all the data. Okay, and with an array you have to move a whole bunch of elements down to delete something, or you have to make a hole for a piece of information. You don't do that with linked lists. You just create a node, find the location, and move pointers around to insert that element inside the list. So the last video we finished up with move last. Remove is a generic move, so it's possible to remove something in the middle. And the idea being here is we're going to remove. You can't really remove a element that doesn't have a good index. That's what they're saying here. I mean, you can't have a -1 index, and you can't have, if there's 10 elements in the array, you can't ask to remove the 10th element, because when you remove something, you want to return that value too. So we're going to return none. Okay, and I don't like the way they use this else all the time. There's no need to have an else. Why don't you? Because if the execution comes here, you know you have a valid index. If index is equal to 0, what you're going to be doing is removing the first element. Fantastic. We've got code for that. It's called remove first. And so call this method. It'll fix up all the head pointers. That code is buried inside that. We're going to leverage in that code. Don't need to worry about that. Okay, now what we're going to do next is get rid of that else and say, hey, listen, if the index happens to be the last valid index, if you have 10 elements, remember the last valid index is 9. That's why the -1. We're going to remove the last element. Got that code that does it. It's going to fix up the tail. So once that's done, what you need to do now is, okay, show you a picture right here. Show you this picture. Move it up a little bit. Okay, I like what he did here. Pretend that this is index 5. So what we have here is index 5, and we want to delete the element in index 5. You need to have a pointer to the previous index 4, because once you remove this thing, okay, to remove this thing is simply taking this pointer and moving it and pointing it over to this. See, that's what you're trying to do, and then you're done, really. So what I'm going to do is say, well, I got to locate the pointer to the previous node. So let me just fix this up a little bit, and this code does it. Notice it's not I is equal to 0. I suppose he could have did this from 0 to index -1. Okay, and it's the same thing actually. Just move that previous pointer, the point to the previous node. Okay, current is just going to be one node beyond next. Okay, previous.next is equal to current.next. Okay, and what that's going to do is bypass. It's basically going to perform this operation here. Okay, so this is current. It's going to say previous.next is equal to current.next. So it's going to bypass this thing. This node is removed from the list. Okay, it's removed from the list. And since you still have a pointer to the current that I've got physically removed from the list, what we can do is just return the element in that current, and you're good to go. Now, you don't have to dispose of it like you have to do in other languages. Eventually, the garbage collector, seeing that node that was pointed to by current has no more pointer to it, there's no pointers to it anymore, it'll be garbage collected eventually. So that's good. And we have a toString, and that toString basically is going to go through and Use a string builder. That's because that's much more efficient than having plus, when you use the plus sign. So we're going to use a string builder, throw in a bracket inside that string builder, and then visit every node. When we find a node, we're going to append that element to the node, move it, and then we're going to put commas and brackets depending upon this logic, and then we need to return the toString. So that's easy code for you to understand. Even easier is clearing. So say you have 1,000,000 elements in the list, this clears them all out. And again, the garbage collector is going to take care of all this other stuff for you to get rid of the memory occupied by those nodes. The last thing is, this is the homework here. This is the left as an exercise, left as an exercise. These are the things that you're going to implement as part of your homework. Size. Well, it's nice to know how many elements are in the size. And then what we've got here is another. Oh, here's what we're doing here. We're defining. I want you to start thinking in terms of iterators. Now, an iterator is basically another object that's tied to the collection or the list for you to iterate through. And so here's how he does it. This is the way you're supposed to define it. And actually, I don't think you need this java.util. All right, then I guess we do need it. Let's go ahead and quick fix this. Let's just import that. So basically, we need to have that import. Yeah, that was missing. Java.util.iterator needs to be included. Okay, so let's go scroll down. Okay, so what we're going to do is say this. Return this object, linked list iterator. Boy, what is that? This is another piece of code that's another class buried in the inner class, but this time this class is not static. And what that means is this class, any instance of this class being buried inside the outer class, will have access to the outer class, the head pointer. Okay, and we certainly don't need this. We don't need that right there. Okay, so this iterator has to implement this interface, and what they're saying to implement this interface is that you have to have a hasNext method, a next method, and a remove method. Not terribly important. I don't even think you need to do the remove method. I think for sure. Yeah, it still works. Don't need to have that. This is old school. Okay, you definitely need to implement a hasNext and a next. See, right now when you created this iterator, there's an internal pointer, current, that points to the very beginning of the list. How do you know you have something to look for? hasNext. Okay, you have an iterator. Is there something being pointed to? Underlying data structure, yes. If current is not equal to null, you're pointing to something. Then what you're going to do is use the next method to grab the element that's being pointed to, move the current pointer, and then return that element. All right. Watch this. Watch this right here. Here's the nice thing about this. I'm going to go to my test program. My test program right here. Here's what I'm going to do. I'm going to go here. Let's put something in the list. Okay, right here. There's something in the list. Iterator of string. It equals, what's this equal to? List dot iterator right there. There you go. Semicolon. Okay, I guess we need to define this thing. Quick fix. Okay, we got it right there. That's imposed that we included that in there. What that buys us is a couple of things. Why we can do a while. it.hasNext. We can do this. hasNext. See this? hasNext. Is there something that's being pointed? hasNext, not hasNext. Okay, something being pointed to there. Okay, if that's true, then it.next. I'm going to print that out. Okay, and then I'm going to say sysout. Alright, let's do sys out. And what I'm going to do is just put a little star so that we know it's coming from this iterator print method. And that's it. Okay, this next, if there's something that's being pointed to, grab it. Process it. Let's see if that works. Yeah, so far poll, that's what comes out. That's what we have. We've iterated through this is the toString that got printed out. But the problem with the toString is you get this one big string. You might want to visit every element in the list. So we've got those 7 countries in the list through here. Now another way to do this is, if that doesn't work for you, if you don't like this iterator, you have to still define the iterator, but you can use the enhanced for loop that says, hey, string country C, we'll say C, in the list, and then what we can do is just copy this right here, copy this in here, and instead of doing 3 stars, let's put 5 stars, and we'll say C. Alright, since this list has an iterator, it's going to use this for loop is going to use this iterator, and if there's something to look at, we grab that country. That country gets placed there. We print it out until there's no more. Until this has next is false. There's no more country. We stop. That's the beauty. Oh, there it is. Same thing. That's the beauty of iteration and enhanced for loops. Okay, so I think what we're going to do here is stop the video, and then what we're going to do is look at why this linked list is so much faster than the array list. Well, I think, you know what, we can do that now. We can do that now. We don't need a separate video. Okay, see what's taking up the majority of the time is not these methods down here. It's saying I want to add 10,000 USAs, okay, to the list, to the beginning of the list, index 0. With a linked list, you know you're just manipulating the head pointers. That's big old 1, okay? And then after we remove those USAs, after we add those USAs, we're going to remove them. Remove at the very beginning of the list. Okay, that just manipulates a few pointers in the front. Now, that's the reason why linked lists are faster, because if we went back to the array list implementation, sure, the program doesn't die, but the back-end implementation is much more inefficient, because if you have to add something to the beginning of the list, you have to create a hole. So if there's 5 elements in the list, you have to move 5 elements down from 0, index 0, to make the hole at index 0 for you to put that USA in there. So you can see right off the bat, you're going to be doing a lot of moving with an array list. And same thing. Now, once we got those USAs, we're going to remove these things. You're going to need to remove the first element. When you remove the first element, you're going to move all those things back. Okay, you're going to have to move, if there was 5 elements in the list, you're going to have to do 5 moves, actually 4 moves, to fill in the hole that's left by the thing that's in the position 0. That's the big issue with this, and that's why you're going to expect a fast, orders of magnitude slower program when you do an array list. Now I think we're definitely done. We're definitely done with this. So what we're going to do is go back to what we have here, and we'll see you in the next video.